Hello friends, in this video we will study the basics of reflection of sound and their two important applications, namely echo and reverberation. First of all, we will study the laws of reflection of sound and then we will study the applications, that is echo and reverberation. So to understand laws of reflection of sound, we will start with an activity. So here you have a source of sound which is a clock, and sound waves from this source are collected through a pipe, and this will be called incident sound. This incident sound is reflected from a reflector, and the reflected sound waves are collected through another pipe, and those sound waves will be called reflected sound. Now we will also study the reflection of light, and we should note one important difference here. So unlike light waves, sound waves cannot travel in straight lines for a longer distance. So when we say a source of sound, sound spreads in different directions, and when we say incident sound, it is in the sense that the sound waves that are collected in this particular direction from this pipe. Similarly, when we say reflected sound waves, the sound waves that are collected from the reflector using this pipe. But here, since it is reflected sound waves, you can hear sound waves only in a particular direction, and that is why the laws of reflection are important. So as you can see here in this window, the line of 0 degree on the protractor is the normal to the reflector. So the angle made by the first pipe, or which we can say the direction of incident sound, with respect to this normal is called angle of incidence. Now the second pipe is at an angle 66 degree currently, and you can observe that we are not able to hear any sound in the present case. So now we will bring this pipe such that it is close to the angle of incidence. Now when it is close to the angle of incidence, we can hear the sound clearly. That is because all the energy that is incident on the reflector is concentrated in this particular direction after reflection. So this takes us to the first law of reflection, which states that the angle of the reflected sound energy with respect to the normal is the same as angle of incidence. The second law of reflection is simply takes into account the fact that the direction of incident sound, the direction of reflected sound, and the normal, they all lie in the same plane. So that is the second law. So we will now summarize what we have done in this activity. So similar to light, reflection of sound also obeys laws of reflection, and we should note that we should not take it for granted that sound waves propagate only in straight line. So whenever we have a source of sound, there will be a spread of sound waves in particular direction, and when we say incident sound, it is with reference to the directing of sound wave through certain devices like a pipe. So when we say that, then we can state the first law of reflection, which states that incident angle of sound wave is equal to the angle of reflection. Incident direction of sound, reflected direction, and normal all lie in the same plane. So this is what we have studied regarding the laws of reflection. So this is the normal, this is the direction of incidence, and this is the direction of reflection, and based on this you can state the two laws of reflection. So now we will study the first application of reflection of sound, that is echo, and we will later examine what are the conditions for generating an echo. So for this, again we will go through a simple animation. So first we should know what is echo. So when sound waves are incident on large obstacles such as a mountain or a huge wall, they suffer reflection. So if there is some listener in front of the obstacle, then he will observe that sound waves that are incident from one side, they are again heard after reflection. So that particular phenomenon can be called as echo, and incidentally the name echo actually arises from the name of a Greek demigod ascribed to a mountain. So let us say you are in front of a mountain and you are shouting hello. So what happens when you do so? Hello. So when you do so, you will hear back your own sound after some time. Now the question is, what is the condition so that we can hear echo clearly? So the condition is that since human ear can differentiate two consecutive sounds if the time elapsed between them is at least zero point 0.1 second. So this means if the reflected sound reaches within the time span of 0.1 second, then we will not be able to distinguish the two sounds. So therefore, the time interval from the time of the incident sound and the reflected sound should be greater than or equal to 0.1 second. So what does this imply for the distance between obstacle and the listener? So suppose at a given temperature near to 25 degrees Celsius, the speed of the sound is 340 meter per second. Then the minimum distance that is necessary for an echo to be heard is given by velocity into time taken. So that is 340 meter per second into 0.1 second, the minimum time required. So that is equal to 34 meter. So what is this 34 meter? This is the total distance traveled by the sound for echo to be heard. So 17 meter in the onward journey and 17 meter in the return journey. So this means the minimum distance for an echo to be heard is 17 meter. So this is the conclusion of this discussion. So we will summarize this. So the first condition for echo to be heard is the time gap between original and reflected sound, and that should be greater than 0.1 second. So this former condition implies the minimum distance between the sound source and assuming the listener is also at the same point from the obstacle. So that distance should be 17 meter. So you should note that echo is possible due to a one-time reflection from the obstacle. Now there is another phenomenon apart from the echo which is observed in closed rooms such as auditorium, which is called reverberation. So first let us have a feel for what is meant by reverberation, and then we will define what is the meaning of that. So this is the auditorium, a small hall you can say. So this is designed so that a person who is on the stage, he is speaking and whatever he speaks is clearly audible to all the people who are supposed to sit here. Now we will start this simulation. As you can hear right now, the speech of this person is clearly audible to a imaginary person sitting here. That is because the sound is being directly incident on this point. Now suppose I increase this particular slider control, and you can see that now sound is not reaching the same point, not just directly. Along with the direct sound is also reaching the same point due to multiple reflection. And because of this, as you can hear, because of multiple reflection, the perception of the audience about the original sound is quite disturbed. So this particular effect is called reverberation. So as you can hear, in the present case, reverberation is undesirable because it is interfering with the original sound. This high level of reverberation is not desirable for the case of speech. But same is not the case with that of music. In music, reverberation is desirable to some extent. So having done this activity, we will now try to quantify what we have felt through the audio. So reverberation is quantified by a parameter called reverberation time. So it is defined as the time interval over which original sound dies down to the level of noise bar background sound. So this is the definition of reverberation time. To give an example, for the hall bar auditorium that we have just shown, if music is not required, then for clear speech audibility, the required reverberation time is 1 second. In case of small halls, sufficient sound absorption happens by audience themselves. So the special care for placing absorber sheets on the walls is not necessary. But in case of big concert halls, it is required to have curved ceilings coupled with sound absorbers on walls and floor. So this is about study of reflection of sound and its applications. So we will summarize this video. Echo is heard due to single reflection from the obstacle. reverberation happens due to multiple reflections. So these are the two important applications of the reflection of sound, and we should be able to clearly distinguish them. So this is all from this video. In the next video, we will study about range of hearing and also application of ultrasonic waves.